In this presentation, I'm going to demonstrate my Java chat application and walk through how it develops across all 5 levels. So level 1 focuses on the basic chat functionality using TCP sockets. So as you can see in the code, it's listening on port 1234 on localhost. Each client runs in its own thread, allowing for real-time communication. But to start the chat, you run the server. Once the server is run, multiple clients can join the chat after entering their name. So I'll write my name down, and now I can get another client, write their name down. Now, as you can see, there's two clients. If we type in the chat, you can see there's real-time communication.
This is level 2 of the coursework. The aim here is to secure communication between the client and the server so the messages are no longer sent in plain text. In level 1, the application used standard TCP sockets. This meant the traffic could be intercepted using tools like Wireshark. So to fix this, I replaced server socket with SSL server socket. The server loads a key store which contains a certificate and its private key, and I've already started the server. Now on the client side, the socket is replaced with SSL socket as well, and the trust store is configured so the client can verify the server during the TLS handshake. So once the handshake is completed, all the data is encrypted automatically on the transport layer. I've already started the client again, and I've said hello here, so we can head over to Wireshark now. We can see I've said hello, and we can see it is a TLS v1.3, and the usernames and messages are no longer readable. So even though a username and password has already been sent, the SSL/TLS ensures that they're encrypted in transit, which is evident right over here, where you can see everything has been encrypted. So level 2 has successfully provided confidentiality and integrity while keeping the application behavior unchanged.
Although encryption protects the data, it doesn't prevent users from gaining unauthorized access by joining the chat. So to address this, level 3 introduces a password for the server. So clients must enter the correct password before being allowed to remain connected. However, if the password is incorrect, the server will terminate the connection. So what we're going to do is we're going to run 2 different clients. One client's going to write the right password in, and the other is going to write the wrong password in. So this one will write the correct password, which is fresh off the boat, and the user is able to join. Now we'll connect the other client and put in the wrong password. We do fresh on the boat. And as you can see, it says the password is incorrect and authentication has failed. The connection has been closed. So without the password, if any attackers know the port number and the IP address, they can gain unauthorized access to confidential conversations. So for level 4, this chat system, it was deployed across 2 different machines. So the server was this PC, the one I'm on right now, and the client machine was on my laptop. However, initially the client failed to connect due to the wrong IP address that I put right here. Because I used the wrong IP address, I used this one instead of this one. Also, I configured the firewall, so I added a new rule here that enables traffic to enter port 1234. So after doing this, the client successfully connected and completed the SSL and TLS handshake. So here I recorded the 2 machines communicating with each other. So here the server starts on the PC, and then I connect the client to the chat on the PC as well. And you can see it's connected to the PC now. Now for the laptop, I also run the client, and now you can see that is connected as well. So now on the PC, I'm going to write a message like hello, and the message has been received on the laptop. Now I'm going to write on the laptop, and on the PC, you can see that message.
This is level 5. The aim here is to analyze the network traffic used on Wireshark and show the impact encryption has on confidentiality. I'm going to compare the plaintext version first, the TCP traffic, against the encrypted SSL/TLS traffic from the chat application. I've already got the server running and the chat client running, and I already have the chat open, so I'll type in a message like hello and send it through. You're going to see in the Wireshark capture right here that you can see the hello. This uses the standard TCP socket. By following the TCP stream, the entire conversation between the client and the server is visible. The username and the chat are readable in plain text. This shows that there's no confidentiality or anyone monitoring the network that can read this sensitive information. I'll now move on to the SSL/TSL encrypted version. And now we're going to run the server and the client, which I've already run. And I'm going to type in a message here, same as before. I'm going to type in hello. I'm going to head over to Wireshark, just like so. See TLS v1.3 here. This is labeled the application data, and the message content is going to be unreadable whatsoever. Just like so, you can see it's been encrypted. The hello confirms a secure session has been established, and although metadata like IP addresses and port numbers are still visible, the usernames, passwords, and messages are fully encrypted. This fully demonstrates how encryption protects confidentiality while maintaining normal network functionality.